take a look at this problem. We got z is equal to 5 plus 5I square root of 3. Now a is our real part, which happens to correspond to our x, and b is our imaginary part, which will happen to correspond to our y. Now when I say correspond to the x and y, some of our formulas deal with x's and y's, and for graphing purposes, same idea. Well, a is 5, so I'll go to 5 on my x-axis. And this is 5 square root of 3, and I have no clue what that's exactly equal to. Doesn't matter. Make it a little bit bigger than 5. And here's what we're talking about. Now this has an r, which is the modulus of z, and it has an angle too, and I made that kind of small. I apologize for that. Now this problem's asking us to put it into find a polar representation. So first thing I need to do is always find r. And r is the same as the modulus of z, and that's given by this formula, square root of a squared plus b squared. So we're going to have 5 squared plus 5 square root of 3 squared (5 squared is 25). In here, we'll apply the second power to the 5 and to the square root of 3. So I'm going to have 5 squared and square root of 3 squared. So we're going to have 25 plus 25 times, remember when you square a square root, they cancel each other away, so it just gives us 3. So we'll have 25 plus 25 times 3 is 75. So that gives us r. R is equal to the square root of 100. And we're looking for a pair of somethings. 100 is 10 times 10. So that pair comes out as a single 10. So r is equal to 10. And then our second item we want to find is theta. Now first we'll look to see if it's on a unit circle. By doing this, it ensures we get an exact value for the angle, if there is one. Now our formula is cosine is equal to x over r, but x is the same as a in this formula, so we got a over r. Sine is equal to y over r, but in this formula sine or y is b. Okay, a was 5 over r, which is 10, which gives us 1/2. Now b was 5 square root of 3 over r, which is 10, and that gives us square root of 3 over 2. So we're looking at our unit circle for a point that's 1/2 and square root of 3 over 2. Well, we got pi over 6 here. We got pi over 4. And you got pi over 3. And their corresponding degree measures. And this is square root of 3 over 2 and 1/2. This one is square root of 2 over 2 and square root of 2 over 2. And this one is 1/2 and square root of 3 over 2. So, as I'm looking at this, the point we're looking for is this one right here, 1/2 square root of 3 over 2. In our unit circle, that's pi over 3. So theta is going to equal to pi over 3. Okay. These are kind of our main elements here. So our polar representation is going to be r, and then we have our CIS, and then of theta. So r is 10, CIS of theta, which is pi over 3. Or, you'll see some books will say 10, and then they'll put cosine of pi over 3 plus I sine pi over 3. So you should feel comfortable with either form. They're the same thing. The CIS you see here is short for your cosine, your imaginary, I, and then sine. Okay, that's a polar representation. What else are they wanting? The real part of z. This goes back to the original form, this up here, and so our real part is 5. They also want the imaginary part of z. And this again goes back to your original problem, which is 5 square root of 3. It does include the I. They want the argument of z. And this is the form. We start with our angle, which is pi over 3. And there's an infinite number. If I look at this this point right here, if I start here, there's an infinite number of those because I can keep adding 2 pi over and over. I can also keep subtracting 2 pi over and over. So there's an infinite number of possibilities for this. So we're going to have pi over 3 plus 2 pi k, given k is an integer, which means it can be positive or negative or 0 even. Now, our principal argument with uppercase A is just theta, which is pi over 3. And those would be our different answers.